Hello, good morning, everybody. Thank you for being here this morning, day 3 of Build, day 1 after the attendee party, and you all seem fairly energetic considering the exhausting party last night. It was great, I thought. My name is Johannes Kebeck. I'm a program manager in the team that manages the Bing and Cortana ecosystem, and I'm specifically working on the geospatial side with our customers and partners on the implementation of geospatial technologies. So today I want to talk a little bit about the geospatial services and solutions for mainly the logistics sector, and how Bing Maps can potentially bring some value to these scenarios. There's a number of new things that we announced during Build this week. And I hope that there is something for each and every one who has some logistical scenarios that you can take away from and hopefully try, give us feedback, and help us improve these services to meet your requirements even better. So the logistics sector, why is that so interesting? It's a massive industry, and particularly the transportation over land is responsible for 70% of the entire freight that is carried over the continent. Now, that is the heavy cargo, the professional trucking, the large logistics companies. But small and medium-sized companies face often very similar problems. If you have a truck for septic pumping, or if you have a business for pest control, then you also have larger vans, smaller trucks, or even larger trucks and tanks that are out there that have special requirements on how you navigate our road network. And surprisingly few of the mapping applications that are out there have addressed the specific requirements that need to be done in terms of route calculation, considering how high a bridge can be, what the weight class is, things like transporting special cargo, chemicals, flammable goods, explosive, and so on, where you need to have special permits. There's very few solutions out there who can help in these scenarios. Now, we have given that long, hard thought, and we were thinking about some of the key requirements and how we may be able to help. And we were looking at 2 main criteria. The services on the right-hand side. What can we do here to help support these scenarios? And then, of course, if you run a business and you have these people who go out and help your customers removing the giant rats from the backyard, then you want to keep track of where these assets are. Who is the nearest service engineer that you can assign to a customer call that just came in? Where is the sales representative that you can bring out and have a discussion with the customer? So we looked at a few of these scenarios, and we thought we have some decent solutions that I want to talk about. We are currently in preview with 5 of those launching this week, and we have given them during the preview code names that take us on a virtual journey around the world. I start our journey in Hurghada, Egypt. Has anybody of you been in Egypt, in Hurghada? Perfect spot for diving. If you're a diver, you have to go there. There's beautiful reefs. You can do boat diving. You can wreck diving there. It's a perfect space. Now, from Hurghada, we will go on to South Africa, Project Johannesburg. And that is not, a vanity name because I'm also Johannes Kebeck. It's really because when I was picking the code names for these projects, I was on a business trip down to South Africa, landing in Johannesburg, and that was how I picked that one. Abu Dhabi in the Emirates, that was a stopover that I made on that way there. And then I will bring you to Nanjing in China, former capital, and we will finish our world tour in Australia, Wollongong, beautiful city about 100 kilometers southwest of Sydney. So let's start our journey in Hurghada. Keeping track of your asset is what we try to target here, not in the large-scale solution, but in a very cost-efficient way where you can have your own tracking solution, your assets that you deploy in your Azure subscription. We have some simple geofencing and reporting and a set of APIs that allow you to extend these reports, the functionality, the look and feel of the solution in Project Hogada. We have built it in a way that you don't require special hardware. The client for the tracking is, in this case, an Apache Cordova application with the Ionic framework around it for the design of the user experience. And it runs in the background, transmits the data to the services that we launch in Project Hogada. And you don't need to have the UI running at all. When you boot the device or restart the device, the background tracking keeps going, and then you can switch it off here on this side as well. The APIs allow us to bring some extensibility in there, and I'll show you a few of these examples. Let's go into a demo of Project Hogada and switch to my browser. So one of the important pieces was we don't really want to claim that we own the entire solution, host your data, and basically cater for every special requirement that you might have. We have a companion website here that will allow you to deploy the solution into your own Azure subscription. All of this will be open source on GitHub. It is not yet, because we need to solve one of the technical glitches here about authentication that currently works very well with Azure Work accounts, but not with the Outlook.com and LinkedIn.com accounts that you can in general use with your Azure subscription as well. But ultimately what you do here is you sign in. This is my work account. I give it a name and say Tech Talk Hogada. I pick one of the Azure subscription that I have access to. Let's say I take this one, and then I click the deployment. It starts submitting. I can open this now in Azure. That is because I changed the network. Let's go out here. Back to that one, refresh the page. And log back in. So we take our Tech Talk Hogada again. I pick this subscription and I click deploy. And now when we go over to Azure, this is the Azure portal with the same account that I was logged in for the deployment. And then you see it creates a resource group. And in this resource group, there will be the Azure database, there will be a web application that hosts the user experience and the web services. There will be Azure Functions who do some analytics on the tracks that we create or that you collect. And if we look at the deployment portal here, so you see it has a little bit of progress already. Let's click this away. Go back here, refresh this one. And then we see our first resources clocking up with the database, the storage account for the analytics, the Azure function, and so on. And now, because I just created that, there will obviously not be a lot of data in there. So let me switch to a project that the team that built this has created and where we have been collecting a number of data already. This team sits in Cairo. So it was fitting that we basically picked a code name in Egypt that reflects the work of the team. So here we have our team tracker, and we have a number of assets in here. Bus 88 is one of those. If I want to have a closer look at where this bus has been, then we can filter this down by day. I can have a closer look on where it has been recently. And if I zoom in, I can even see the individual speed, the heading, the accuracy, the timestamp when it has been worn, and so on. So when you launch the application for the very first time, you need to register your device, of course. And if you want to add a new device, then we made it very simple by creating these barcodes. You point your mobile application, this tracker, that runs on your iOS, Android, or Windows application on this device and configures it for that backend. And then we assign it to an asset. So essentially, if you're a driver of the pest control company, and today you drive in truck 1, it's your phone, tomorrow you drive in truck 2, then we basically take the device and assign it to a different asset. Here in this section we can define geofences. So when we are looking at the geofences that we created around, for example, the Washington State Convention Center, every time one of our assets enters or leaves this Washington State Convention Center or the area around it, we send out a notification that tells us about it, so that I know at any time when one of my assets arrived at the customer or leaves there again and is available for the next trip. We have some reporting around this as well. So you saw that there's these trips that we detected, so it's not just individual points, but the Azure functions, they run on the data in the SQL database, and they identify when a trip starts and ends, and they calculate the mileage, and some of these reports tell us how many miles an individual has made, so that we can use that for billing purposes or tax purposes, for example. So that was a quick run through Project Hogada and keeping track of your assets. Now, if we have these little trucks or larger trucks, as I said before, they have special requirements about the dimensions that they have, certain things and roads where they would not like to drive. Here we have such an example of why that is an important piece. This is a bridge at the Arboretum in Seattle, and you see quite a few of the hit marks here on this arc of the bridge. And they really call it affectionately the guillotine, because things like this happen fairly frequently, right? So this driver overestimated the height of this bridge, and he hit the arc and lost the entire cabin. So this is quite a bit of damage on the infrastructure and, of course, also on the assets that you have. To help with this challenge, we created Project Johannesburg. It's essentially a truck routing API or a routing API that can be used for vehicles that have more than the standard size of a car. It takes into consideration specific speed limits for trucks that might be different than they are for a standard car. The height, the weight, the length of the vehicle, the preference to avoid crosswinds or grounding risks, the long wheel stand if you cross a railroad track that bears the risk that you ground this truck as well. So all these things are put together in there, along with compliance requirements. If you have hazardous goods, then you may not be able to drive through a certain tunnel with a flammable cargo, right? So these sorts of things are implemented as well. Let me walk you through a couple of these scenarios and go back to my browser window. So first, let me start with one route that I have pre-configured here, and we are looking at a truck that has a certain height. And when I calculate this route now, you see in red, this is the route that the car would take. In green, this is the route that the truck would take. So it's substantially longer. And why is this? Let's explore this in our street side imagery. And then we will see there is one of these low bridges that the truck of the size that I defined will not be able to navigate. So that's why we took this long way around. Let me give you another example. Here we have red, again, the car, green, the truck, and it takes a rather different route. Let's look at the street side imagery again and see why that is. There's a fairly tight turn here, and the long truck will not be able to make that. So rather than taking the right turn, which is the shortest way, it will take the left turn and then drive around this obstacle. One other example. Here we have a truck that is heavily loaded. It can't drive a gradient that is steeper than 10 degrees. So if we calculate the route here, the car can easily take this. The truck, again, takes a detour. And why is that? If we have a closer look, this one is going here. It seems fairly flat, right? But we can see from this traffic sign here, there will be a gradient of 19 degrees, and the truck doesn't want to drive there. And then let me show you a final scenario. Here F stands for this truck is transporting flammable cargo. And we're looking at the segment of the route in Pennsylvania that goes, the car goes here through the Liberty Tunnel. And this Liberty Tunnel doesn't allow any flammable or explosive cargo on the truck. So the truck has to take the long way around here as well. So those were our stopover in South Africa. Now let's move on and have a look at the Middle East, Abu Dhabi. So distance matrices are fairly common when it comes to cost calculation, when it comes to certain things like route optimization as well. We have added a twist to this distance matrix API by providing also a histogram of what the traffic will look like over the next 7 days. So you can have a matrix with the start, with the origins and the destinations, and in each cell of that matrix, you can have up to 7 days worth of travel times that we calculate here. So one of these things that you see is a route that I have picked, 7 days of travel time. You see the peak traffic hours in the morning and in the evening, and in between it's fairly flat. So we know when it's a good time to leave our office or our yard and drive out to the customers. Let me give you one example here on our Abu Dhabi project as well. We have here a number of stops that I want to make, and I want to optimize these stops in the right order. So our little pest control business that we have has had 5 calls from customers that we want to visit during the day, and they came in the order 0, 1, 2, 3, and you see already 0, 1, 2, and then back to 3. That doesn't seem like an optimal route, right? So based on the distance matrix that we have, where we can provide predictive traffic times for the time of day as well, we have run a genetic algorithm that has optimized the stop order and then calculated the route based on that. So we start here at our office, and then instead of going to 1, we go first to number 3, then we go to number 1, then we go down to number 4, up to number 2, and then back into our garage and the workshop to finish the day. Now, from the Middle East, let's go to Asia. So time-based search is a very interesting thing. So you don't want to drive too far so that you actually have a lot of investment in going to the customer, and the profit that you make of that is almost eaten up by the travel time and the payments that you have to do for your drivers. So let's say your maximum area that you want to cover is like 2 hours drive time, right? Or let's take another scenario. You are interested in, completely unrelated to the logistics sector, you are interested in a new property. You want to work at a certain place and you don't want to commute for more than 45 minutes. And you want to do that in a way that you arrive at 9 o'clock in the morning in the office. So what happens if we call our API to find out what is this area that we can cover in such a time frame? So here we have Project Nanjing, and I say I want to work here in Seattle. I don't want to drive more than half an hour, and I want to arrive at 9 a.m. in the morning, and then let's see what this area is where I could look for a new place to live. So this is what we have calculated here, and I can also do calculations that say I don't want to drive toll bridges because it becomes expensive if you do that every day, so it would exclude, for example, the 520. And if we look between the traffic-based isochrone and what I would have calculated if I would not have considered the traffic, you see there is a very large difference, right? So if I don't consider the predictive traffic at this time, I could have been tempted to look at as far up as Everett, and there is like a 15-mile or 10-mile difference, 15-kilometer difference of the area that I can cover. Now, from Nanjing, let's go on to Wollongong. So Wollongong is something that is more for the home seeker or when you plan a vacation, that gives us a score for the attractiveness of the location based on proximity to certain points of interest. So in this case, I have selected a few points of interest, and I want to find out what the score for this is. Let's do that in a real demonstration as the final wrap-up. We're looking here at Bellevue, and I want to find out if I walk for no more than 15 minutes, how many of these attractions that I'm interested in, that I put together here, can I cover? And we see I have this broken down by each category, and in total of those that matter to me, I have a score of 121. Now, if I look at Redmond in comparison, there is a total score of 98, not bad either. Let's have a look at Sammamish, right? And we see that score here is a lot less. Less restaurants, less bars, but quite a few of childcare services, right? And the total score that I've given is now not weighted, but if I want to apply a weight to that, then obviously I can have a relative score to that as well. Now, that was a very quick run through these new projects and previews that we have launched today. All of this is available since built on labs.cognitive.microsoft.com. We collect feedback for each of those, and we would encourage you to try it out. Use user voice to provide feedback to us. Tell us what you think and what else we should do. And yeah, with that, I thank you for your time, for being here. And we are over there at the booth if you have further questions.